cut it now. All right, trick proofs. Again, prove, verify. The words are interchangeable. When you see them, you're going to be doing the same things either way. Okay, what you can and cannot do. Do you see that this does not say solve?
Yes.
Right? Because you're not solving here. You are not allowed to move things around. You can't like subtract the cotangent theta over here and do some work. Or you can't divide the secant theta this way and do some work. There are no moving things back and forth.
Assuming if you did, you wouldn't answer it anyway.
Right. What's on the left stays on the left. What's on the right stays on the right. Okay. What you will do is you will pick a side. Sometimes it's better to choose the right side. Sometimes it's better to choose the left side. Sometimes it really doesn't matter. It works out the same, like difficulty-wise, either way. Okay. So you pick a side, and once you pick a side, that is the only side that you will touch, the only side that you will change. You will not touch or change anything else. Got it? Okay, so because I've done this already and I already know what it's going to look like, I'm going to pick this side, and we're going to talk as we go as like some thoughts and ideas of what side, how do you know what side to pick? Okay, so I am picking the left side. Now what you do is you bubble it in. So when I'm grading your work, I can tell, oh, so-and-so picked this side, and I'm looking for the work that reflects this side. All right? Now, what is nice is we know what the answer is. We're trying to get this, we're going to manipulate it, and we want the final answer to look like this. So this is pretty much like last night's work. Something like this. Only thing is, you're given an answer. Does that make sense? So this is last night's work, and but I'm saying, hey, here's the answer. That's what you're trying to make it look like. All right. So any suggestions? I mean, just like what we did when I was going over homework. What could you change these to?
Sine and cosine.
Okay.
All
All right, so tangent is sine theta over cosine theta. And no squareds. Do you guys see that? Okay, and then cotangent is what?
Cosine over sine.
Cosine theta over sine theta. Yes? Oh, can I cross multiply? Or cross reduce? I'm sorry, can I cross reduce?
No.
Why not?
It's addition.
Addition. What about up here? Do these reduce to 1?
No.
Same reason?
Yes.
Right. If this was multiplication, yes, that would be 1. If this was multiplication, yes, you would reduce to 1. Addition doesn't work the same. All right. Thoughts? Yes. Good job. He said add them together by finding a common denominator. Was that one of our tricks to try that we had? Yes. Number 5, get a common denominator. All right. So he's saying rewrite it with a common denominator. What is the common denominator going to be in this case?
Cosine and sine.
Cosine and sine. All right. So I'm going to take my first fraction and multiply by what's missing. What would I multiply top and bottom so that the denominator is sine theta cosine theta? Well, would I need to multiply by the cosine theta if the cosine theta is already there? Right? Do you agree it's just sine theta that's missing? Okay, so sine times cos is the sine cos. And what sine times sine? Sine squared theta. Plus, all right, second fraction. Elisha, can you tell me what to multiply top and bottom by to get this to look like this? Good job. Cosine theta. Does everybody see that cosine sine or sine cosine is this here? Do you guys see that? All right, and cosine times cosine is cosine squared theta. All right. Thoughts? Suggestions? Yes.
Could you do, since sine squared plus cosine squared equals 1, could you turn that into 1?
Good. She said this is a Pythagorean identity, and this is 1. So she's saying write it as 1 over sine theta cosine theta. Now, as I stated before, you have a goal. This is what you're trying to get. So this is kind of like keeping your eye on where you're trying to go. So I'm here, I'm trying to get this. Any suggestions?
Weren't they equal?
Yes.
Because,
Can you turn them both into separate fractions?
Can you turn these into separate fractions? And I heard you say, are they equal? Are they the same? All right. We talked about pulling apart fractions, it was yesterday. Pulling apart multiplication fractions is different from pulling apart addition fractions. On this one, I do not need a common denominator because it's multiplication. Do you see that? Are these two equivalent?
yeah.
Yes, would I just multiply the numerators and get 1 and multiply the denominators and get sine theta cosine theta? Okay, why do we do this? Because 1 over sine is what? Cosecant. And 1 over cosine? And is that the same as secant times cosecant? So here's how you end it. Equals secant theta times cosecant theta theta. Now, does it matter that the order in which they appear is different?
Yeah.
Cosecant, secant, and secant, cosecant. Does that order matter?
Only if there's a subtraction.
Good. Only if it's subtraction or division, because subtraction and division are not, there's a word, starts with a C, commutative. Good job. Multiplication, addition is commutative, so the order doesn't matter. So are these truly equal to each other? Yes. All right. You don't need the check mark. That's just check. We are done. Now here's what I expect on the test. Are you ready? Phones put away, please. All right. I often have kids like have random work in here and write this, and when I mark it wrong, they were like, look, Mrs. Torres, my answer's right here, and why did you mark me wrong? Is this really your answer?
It's always going to be your answer.
Right. Because this is just pretty much what we have up here written twice, right? And anybody can write this twice and just put junk in between and say, I'm done. All right. This in here is your answer. Your work is your answer. So when I grade these on the test, I do have to look at every single problem you do like this and check every single step for every single kid, because not everybody does it the same way. And sometimes students go way out and do something like way different from what we would have done. And that's okay. Just know that you need to be clean and neat. Yes?
So, like, what you're saying is sometimes people just, like, guess that?
Yeah, people will get stuck and like, well, Mrs. Torres won't know. I'm just going to write a bunch of junk in between. And at the end, I'm just going to write this twice. Twice and twice and box it. And they're like, oh, good. But no, you're not going to trick me, because I check every step, every problem. And I look, and if you do it different, but like my test, I have multiple versions or multiple ways. And if you do it different, I have to sit there and make sure that all your steps are correct. So it does take a while.
The one problem I'm going to try to trick you.
Yeah, you don't want to try to trick me in the test, because those are your points.
This is only problem 1.
What was that?
I said, this is only problem 1. I'm waiting for
The harder ones?
yeah. I'm waiting for where it becomes complicated. And it's wrong back. And then you don't have to step in. It's gonna be complicated and you're I'm waiting for it to become complicated and you're gonna hate it.
No. All right. Questions? Okay, so what I'm going to be looking for when I'm grading your work. You've bubbled in the side you picked, so I'm not guessing, well, does this work match this side or this side? And sometimes your work is everywhere, so you bubble on the side you're working with. Now, if you pick the left side to work with, can you get halfway through and then, oh, I'm going to change this and move it around and I can get this to look the same? No, you only mess with one side. So you bubble the side you're messing with, you do all your work. When you are done and you're saying, hey, I got to where I needed to be, you write your right and you box it. Now, why do we have this last step if it's not really necessary? This is telling me you're done. You got it, you finished it, did everything you were supposed to do, you are done with the problem. Again, is this boxed in piece your answer? No. This in here, your work, is your answer. All right. Number 2.
So is there like a specific reason why you can only mess with one side?
That's how trig proofs work. You're trying to prove that one is equal to the other without manipulating both sides. It does.
Say, for instance, in the last problem, we put 1 over sine theta times 1 over cosine theta as the side we didn't do as much with. So, like, is that like detrimental?
Well, you would just get it wrong because it's not. You're not supposed to do that. I mean, technically, it is correct, but it's not the way they work. So, like, you got this to this part, and you said, "Oh, I'm going to change this to 1 over cos and 1 over sine." No. Don't touch this side. Just continue this one until you get it to look like that side. Yes?
No, what's up can you give us doing this to pick the side that we will use it?
Oh, like how? Okay, good question. I was going to discuss it on this one here. It doesn't. Okay, sometimes it just flat out doesn't matter. Pick a side. It go with it. Most of the time, you want to pick the one that's more complicated, has more to it, because you can take something that's bigger and simplify it and break it down and make it something smaller.
So, the reason I'm asking is because, like, on the first one, you have 2 terms, and in one term it will build up, well, in my opinion, a little more difficult to make the one that has 1 term, 2 terms.
So it would be more difficult to do that. Yes.
Yeah.
So those are things that you're thinking about. Like same thing here. For me, it would be more complicated to pick this and try to make it into something bigger versus taking something bigger and cleaning it up to make it something smaller. Do you see that? So yes, you are correct. Try it tonight and then report back to us on Friday. All right. So we're going to pick, I'm going to pick the left.
Ms. Torres,
Yes.
why do people do this in the real world?
To make high school students' life miserable.
Great, that's exactly what I was expecting.
It's the
So
answer
for
I
you to
wanted.
say.
I mean, like, I don't want it to be true, but I like the fact that you own up to that. I appreciate that.
One thing I did want to say, because a kid did ask in my morning class, are you ever going to get one where it's not going to work? No. There's never going to be like, haha, gotcha, it didn't really work, you did all that work for nothing. No. It's if it says prove or verify, it's going to work.
And also, you said it's equal. So
Yes, yes, I'm telling you, they are equal, prove it. It's not like they're equal, prove it, haha, tricked you. It does, no.
That'd be
what
true
about
or
April
false.
1st, man? What are you going to do that first thing?
Just for fun, I will. All right, I will give you a hint. Are you guys ready? This one is super easy. You can get it done in one step. You have it already?
I already got
Okay,
it.
hold on, hold on. The rest of you guys try it on your own. I'll give you one hint in the numerator, GCF. Try it. If you've got it already, you're holding on. If you haven't tried it yet, you're doing GCF in the numerator.
Ms. Torres, I have a question.
Yes.
So, like, there's multiplication, there's multiplication here. So, like, I know this is a little G. So, or just this effect.
Yeah, if that wasn't there, then yes, you could reduce it. Do you mind if I say that out loud?
Yes, yeah, go ahead.
The question was, can I reduce this here because it's multiplication, or does that addition change it?
That the addition changes it.
Right, because how many terms are up here?
2.
2 and 1 in the denominator. Can I reduce when there's multiple terms?
No.
No. But we can GCF
Yeah.
and
then
possibly reduce. Tell me what you GCF.
I GCF the sine of x
All right, sine of x, because they both had at least one. Okay, keep going.
Cosine plus sine x is going to be in parentheses.
Cosine plus sine x.
Yes. Over sine x. So on the sine of x.
And what are we left with?
Cosine plus sine x.
Was it a lot easier than you may have thought it was going to be for this one? Did anybody do it? I'm like, oh wow, that was really easy. Yeah, they're not always this easy, unfortunately, but we do have these rare instances where they are.
I can just start on the other side and just multiply it with sine over sine.
A lot of the time,
I
these
mean-
stuff look complicated and they're actually easy. The simple ones are what's so complicated. Like the ones was like,
I get what you're
sine
saying.
X to the 10. It's like, what? Just one term.
But yes, you could have picked this side and did sine over sine and then multiplied by sine over sine and then combined it to one fraction. But it's not like this way was hard.
No.
No. But yes, both either sides would have worked. But what's nice is that if you did pick this side, you would have an answer to know what you're aiming for.
Yeah.
Yeah.
Yes.
All right.
Does that statement apply to both ways?
Yeah, that does.
Wait,
So there are some times where one side is easier than the other. And there are some times where it really doesn't matter which side you pick. And sometimes you will know, like, oh, there's no way I'm going to pick that side. Number 3, tan of beta minus cotangent beta. Beta. If you don't like it, you can use theta or x.
And what's the point of having beta in the problem?
I'm using beta. I'm not going to change it.
So you like to switch it up sometimes?
Yes, and it's like this on worksheets and quizzes and tests and textbooks. I'm just preparing you so when you see it, you're not like, what the heck is that?
What the heck is that?
So we can do it early.
There you go. Tan
I mean, I
beta.
can still be like, what the heck is that? But, I mean, I just know it's beta.
Okay. Okay, thoughts? Which side?
Right side.
I'm assuming the right side.
Okay. Okay, I'm going to let you guys try it. I will give you one hint, or actually I will take the one hint from anybody in class. What are you saying with your hand gestures? Can't think of the word, yes.
Difference of two squares.
Difference of two squares. Good job. All right. Okay, so I'm going to let you try it. Their suggestion is do the top difference of two squares. And I'm hoping when you do it, you hit it like a quick moment where you're like, oh, I see it.
Oh, I see it.
Good, good,
Oh, I still have yet to see it.
good.
Don't worry, you're gonna see it.
Yeah, you will. It's not a extremely complicated one.
It's just a more complicated looking picture.
I'm not afraid for it. What is it?
My favorite name.
When it's like a squared minus b squared, it's a plus b minus c.
Oh, square.
Once it looks like almost everyone's done, help each other. Talk to your group members.
It's still over there. That's not
Okay. So, yes. Yes. Did you go already? No? Yeah.
I drink a little bit of water.
All right. Difference of two squares. So this is tan beta. Does it matter if you do plus or minus to start with? No. Tan beta plus cotangent beta. If I did plus first, what would the next one be? Minus. And then what ends up happening? It reduces. Okay, yeah, thank you. Okay, so this with this, and what are we left with? And is that what we're trying to prove? So we're ready to, it's exactly right. So you're ready to write it out. Minus cotangent beta, and you box it in, not to say that this is your answer, but that you were done with the problem. Do you agree to not take that much work? Okay.
That's where it gets harder. Not on this one.
Okay. Number 4. 2 minus sine squared x equals 1 plus cosine squared x. I will tell you, this is one where it really doesn't matter which side you pick. So don't sit there too long thinking, ooh, well, this looks kind of like, no, doesn't matter. Pick a side that you feel is easier for you and go with it. I'll give you one hint. You're using Pythagorean identities. All right, go. Anybody want a hint, a suggestion, or you want to
Nobody
just
wants
try?
to.
Good, good, good. I like it.
Speak for yourself.
I'm not gonna that. Adjust. Got it? Where is it? So I'm gonna go on that side. I'll use one
All right. Anybody get it?
Yes, ma'am.
Yes? Anyone else?
Man over here.
All right. Yeah, you got it? Okay. Anybody ready for a hint then?
Yeah.
Okay.
I've been ready.
Which side did you use? Right side or left side?
Right.
Doesn't matter?
Doesn't matter.
Okay. I heard some rights. So here's what I would suggest. Here's what I look at. If I'm using this side, always keep your eye on what am I trying to get. I'm trying to get it to look like something with a
Sine.
sine squared. So is there any identity I have for 1 plus cosine squared? Let's address that first. Is there any way to get this to 1 plus cosine squared? That's mathematically impossible. There is no way, ever. So cover the 1, bless you. Cover the 1 and think to yourself, what can I change cosine squared to? So that's where I'm going to leave you. 1 plus, and then you're changing the cosine squared to its identity. So that's continue. I want you to continue if you were stuck to it to begin with.
So
Ah.
have the identities because I wasn't here.
You'll want to either get a copy, like take a picture from mine, or I can go make a copy for you, or if you go online to the cwmath.com. But they're right here. Yeah. All right, anybody have it? What does cosine squared become?
I get it now. It's 1 minus 2 sine, 2 sine.
1 minus sine squared x. Okay, so stop there. Did anybody reach that aha moment? Like, I get it? No, still not yet? Some of you? Okay. So do you see, first off, red and red. Cosine squared is cosine squared 1 minus sine squared.
Yes.
Cosine squared is 1 minus sine squared. Do you see that? Now, if it is, then that 1 is still there. What's 1 plus 1? 2. And do I get what I was trying to prove?
Yes.
2 minus sine squared x. Did anybody use the left side or wants to see the left side, that it still works? You did? Did it work? Or do you want to? Okay. All right. So I'm going to show you the left side. Same thing. I'm going to pretend I'm bubbling this side. Bubble, bubble. If I'm working with this and I'm trying to get it to a cosine squared, do I have 2 minus sine squared as an identity? No, I'm going to do the same thing. I mean, there's multiple ways, but I'm going to treat it the same way I did this one. I'm going to cover the 2 minus. So I'm going to do 2 minus, and I'm going to do squiggly here and a squiggly here. What does sine squared become?
1 minus cosine squared.
Now, there's one thing I have to keep in mind here that I did not have to worry about on the other one. Anybody tell me what it is? The minus. This is 1 minus all of this. So what do I put around it? Parentheses and distribute. That's the only extra thing you have to worry about. Because it's minus all of sine squared. So if I change sine squared to 1 minus cosine squared, it's minus all of it. 2 minus 1 plus cosine squared x. Does it work?
Yes.
Yeah, what's 2 minus 1?
1.
And is it the right side?
Yes, please.
All right. Make sense?
Kind of.
Kind of. Yeah, it's definitely going to take practice. Again, it's not something you're going to take home tonight and be like, oh, a piece of cake, I got it. Expect to struggle. Phone a friend and get some help. All right. Number, what was that?
Would you like to use your phone a friend?
Oh.
Remember, you only get one.
So make sure it's the right friend.
And the right problem.
Oh my.
Lions, tigers, and bears.
I know. I just realized the time. Good grief. Okay.
You don't have enough time, you have too much time.
We're going to have to rush. We have another lesson.
We don't, man. We don't.
All right. Okay, so I messed up somewhere.
Yep. You put a cube.
The cubed is actually the right one. This is the one that was the mistake. This should also be a cubed. I know, we would wish the cubed was the mistake, but it wasn't.
Cubes are always mistakes.
All right.
I know what you're talking about.
Okay, now because of time, I'm going to go straight through it. I had kids ask me this. I'm going to say it quickly. They said, can I do this and reduce it? Okay, it's the same question I asked earlier. Can you write it as quantity cubed, expect to distribute, and get this? No, you cannot. But it's what kind of factoring that you learned last year? Yes. The SOAP, the cube factoring. You guys are correct. All right, because of time, I'm going to do it with you. So A minus B, A being tan x because you cube root it, minus B, B being cotangent x. I know. A minus B, same. And then A squared, tangent squared x, opposite. And then the product of A and B, tan x, cotan x, always positive, plus I lost where I'm at. Cotangent squared. All over tan x minus cotangent x. And I apologize, I went right through it and said I'm going to help you with it, but I never said, hey, we should pick this side. I'm assuming you guys all bubbled it in. All right. This is nice. What ends up happening right off? Cross cancel, cross reduce, or reduce. Now, here is a suggestion I have for you. Well, actually, can anybody give me any suggestions in here? Change everything to sine cosine. Before you do that, that is a good suggestion. Look at what we're trying to get. Does this have any sine or cosine? So we might have to do it, but we may not want to.
You could change tan cotangent maybe.
Okay. Okay, so he said you can change tan cotangent, but you never finished it, so I don't know if you were going to say it.
I said that we already have cotangent squared x.
Okay, even better. All right, so he's saying, hey, we already have the cotangent squared x, so that's always a good thing. Keep your eye on what you're trying to get. So I'm going to cover this guy. Is there any way, I'm going to leave you here in just a little while because we have another lesson to get through. Put your phones away. Is there any way to get this to be secant squared?
Yes.
How do I know I'm trying to get this to secant squared? Because I already have the cotangent squared. I'm going to let you do it fast. Keep in mind, somebody gave you a hint for this one already. What was it?
1.
This is 1, because the reciprocal function is multiplication. Go. Yes, I love those aha moments.
Do we have to try this sine cosine and like solve it and then do it, or can we just use like the Pythagorean?
You can just use your Pythagorean identities. You do not have to do all the sine cosine if it's not necessary, and it's not on this one. Did anybody get it? Yes? All right, what did you do with the tan squared x plus 1? Is it one of your Pythagorean identities? What does it become? Secant squared x. It's not even a rearrange. It's as is. Tan squared x plus 1 is secant squared. And so we say, hey, secant squared, that stays. And is that what we're trying to prove?
Yes.
And you are done. Not that bad. Do you agree? Again, it's going to be harder when you're doing them on your own because you don't have anyone guiding you like, hey, try this. But practice, practice. Are we good?